Okay, so question 9, similar problems again. We have 50 newtons east and 100 north, so I won't go through all of these, part A and part B. I can draw the vector diagram for you to start off with if you like. So if we have 50 newtons east and then we have 100 newtons north, then the resultant vector is going to be here. So let's just call that F for the resultant one, and just remember to get your bearing in there. You can either work out your theta there and then turn that into conventional bearing, or you can work it out this way and work out the bearing in here as well, just by making the right angle triangle here, like that. These ones, just remember that that's 5,000 newtons and that's 2,000 newtons. So either put your magnitude in terms of newtons, or you can put them in kilonewtons as well when you work those out. Either way, you can work it out that way. Now, I might go through question 9c simply because a lot of people found these hard to put into their calculators, so I'll grab the calculator up on the screen as well when we're ready to use that one. So let's start off by doing our vector diagram. So we have 5 times 10 to the 4 newtons south and 2 times 10 to the 4 newtons east. So let's start with our south. So 5 times 10 to the negative 4. Did I say negative or positive 4? Before I'm not sure. So 2 times 10 to the negative 4 newtons east. That way. So our resultant force is going to be, let me get F, and yep, that'll be a nice theta, because then that'll give us our conventional bearing as well. So our magnitude or size, F, is equal to 5 times 10 to the negative 4 squared plus 2 times 10 to the negative 4 squared. Now let's work that. Let's use our calculator to work that out. So if you have a calculator like this one, let's find our keyboard, and we've got our square root thing in here. So we've got a bracket, 5 times 10, and then when we want to raise something with the power of it, it's this little button there, and we go negative 4, so it's like a little hat. And we square all that. Where's it squared? I guess I can just use this. Squared plus 2 times 10 to the negative 4, all squared as well. Okay, so if you're given indices like that, you can just put them in your calculator like that. 5.38. Oops. Good. So 5.38 or 5. I'm going to round it up to 3. So here's 5.39 times 10 to the negative 4. Okay. So that's our magnitude. And for our direction, if we put in theta equals 10 to negative 1 of 2 times 10 to the negative 4 over 5 times 10 to the negative 4. See how, just like with any other fraction, these 10 to the negative 4s will cancel out. So you can just put that into the calculator. If we find our, what's it math to? Fast code trick. 10, 2 divided by 5. So we can just put that in the calculator. It's a lot easier. Like that. So 21.8 degrees. Now if you notice up here, we've got this little e, that means a times 10 to the negative 4 times 10. That e is times 10. And if you want to make your calculations easier, if you don't want to put the times 10 to the negative 4 inside these brackets, because they're the same order of magnitude, then you can just leave them out. And it would come out as 5.385 still. That'd be the square root of 5 squared plus 2 squared. And then you can times it by that 10 to the negative 4 afterwards, so you don't have to put that all in the calculator if you don't want to. Let's just finish writing this one off. So it was south, 21 degrees east, because it's already in our conventional bearing. Okay.